For those of you who didn't take it now, please remember 1 p.m. Okay, last week, are you still on chapter 2 on your software project management? Still on chapter 2. Okay, so we are on chapter 3 already in our tutorial. And last week, what did we learn? QP, QA, QC, right? Yes. Which you guys, as I said, are very familiar because you did it last step already. Today we are still going to be on chapter 3, but we're going to focus the tutorial on the calculation side. So there are a few calculations inside there. Let me write it down for you. So there are a few calculations in chapter 3. One is what I call, how do I call it? I call it clock based because I follow your clock base. And I'll explain what this is. The other one is function point analysis. They call it FPA, right? And the third type of calculation is, there's no special name, but they calculate the defects and the documentation per function point.
So base.
Okay, so a question I have for you, since you did this subject last step, did you do any of these calculations in the software quality management? No. No calculations at all? No. Okay, so then I'll go with you. So what is all this? So if for those of you who don't know, and I think you are new to this, guys, we can finish this early, then you can talk afterwards, okay? But let's try to finish this. This stands for lines of code. This K stands for thousands of lines of code. K is, 5K, 2K, but this 1K, 1,000 lines of code, okay? And in this calculation, basically what you do is you count the number of lines of code literally in your whole system that you build. Okay? And based on a formula, which I'll show you afterwards, you can calculate your productivity of your development team. And you can track your output, basically. So how productive, how effective is your software development team? So this one gives you that. Okay? Then we have, but you see, this calculation is very internal focused. You look at your code, count how many lines there are. This function point analysis is slightly different. It's more outward looking. You count the number of functions in your whole system. And the functions are the number of input fields you have, the number of output fields you have, the number of reports you have, the number of query screens you have. So it's very detailed. I'll show you an example of how to calculate that. And based on this, so basically you look at your functions or your functionality, and what this gives you, it gives you a feel of how much effort you need to do to calculate this, to do this, okay, to do your system. So it gives you a feel from that perspective. Then the last one, doesn't have a special name, but you calculate the number of defects and the number of documentation. So I'm sure you haven't count any calculation that counts how many pages you have in the documentation. This one counts that. Okay? So you know you need to count how many defects you have, how many documentation pages you have per function point. And this one really will give you a feel of the quality of your system and the maintainability of your system. Okay. So we are going to do this without you having gone through your lecture. So what I'm going to do is show you some of the relevant areas here first, so you get an idea before we look at the tutorials. Otherwise, you'll be walking in a little bit blindfolded. Okay, and my PC has hung. How old are these PCs? It's hung already. Yeah, it's really hard. Okay, so I'll use my notebook. You have to wait for a few minutes.
没有超限了吧？超限了吧？
有 open review。
我的是窄。哇 ，Jeffrey 关跟这个有什么？
有钱拿。
那个，
那东西拿去。
Okay, definitely. Okay, so let's try mine.
100几够圈呐，屌你啊！My D 这个Speed One 零售超市零售店，妈的逼！点了我两个设计199不是很出来，是啥？我在。应该还没有吧？应该还需要实习。
60买个可以再提个吧。
肌肉哎，放电动诚实了吗？你想换？阴漏啊，阴漏啊，阴漏啊！
So you click the Wi-Fi. I think it's the Wi-Fi one.
Wi-Fi? Oh, it's a Wi-Fi. Why would it be Wi-Fi? Okay, it is Wi-Fi. Yeah, I know. I use some of the internal systems. Okay, let me do this. Okay, you guys can relax while I connect. Hopefully I see better.
这是很有运气吗？这是很有运气吗？一台未必哦，超过10天了，看不懂。
这个不认识啊。
花来，你妈！
不是女人。
有看你的地方，他讲整个场都那个啊人毕竟不一样。看到了，看到了，看到了，他们吃瓜嘞，只是片。
打不打？不打。
Sorry guys, we can start now. I want to state some slight typo that I said just now. We're actually doing chapter 4, which is software metrics.
哇，飞掉哦
We are a bit ahead. But I
！It's too big.
yeah, but otherwise we all can sit down here and chit chat, right? So let's try to do a bit of this. So this is chapter 4. So I will go a bit slowly because I know you haven't done this. But this is essentially the chapter which has these 3 calculations which I want to walk through with you. And I want to show you a bit of what your lecture covers. Before he starts the lecture, I think it would be good to go through. Because I went through your lecture notes. I think if you try to read it on your own, it might not make more sense. But when you hear a lecture speak, hopefully it will make more sense. But now that we are explaining it in advance, hopefully it will make even more sense. Okay? So, I can hear that. Okay, let me show you a little bit of what he is. It's a he, right? Your lecturer? He, the guy, right? Older guy, right?
Yes.
Very old.
中文怎么讲老师哦？
Not allowing anyone to
Oh, really?
我没有看过来。 Yeah, I never seen the lecture before. From week 1 to now.
That's because you're sleeping now.
He never come.
You never come. I think you have to do it.
Yeah. Sometimes come on. I come in the last minute.
Attendance not together.
Outside the lecture there, I get the code already, I go already.
That's what I heard. Okay, so let's talk about this, okay? I know it's new for all of you, but this is the first one, the clock base. And remember, you start off with lines of code, and this one really is to count the lines of code and to measure your productivity. So just like last time we did some of the software project management techniques where we can see which project is better than the other, this one is the same thing. You can compare project A and project B, okay? So what we get are numbers like this. So this project A, this example, has 306,000 lines of code. All the code that you've written for the project already. So you assume that this project is already reached the end and it's completed already. Then another project B has 256,000 lines of code, okay? But you know, you cannot actually compare apples to apples, right? Whether which one is better, which one is more productive, right? Because it's not the same amount of lines of code, right? So that's why it's called not normalized. Then later on we have to normalize by dividing it by 1,000, so I'll show you that. Then you also keep track of the number of errors and defects. So in project A, there are 288 errors during testing. Project B, there's 233 errors during testing. Defects is after you've passed the testing, then you let the users use the real environment, the user found some problems there, right? That's why you see the number here is smaller than this, because this one during your software testing you discovered, and this one defects when the end user discovered while they're using it. And you also take pages of documentation. So you get all these variables, and you normalize them, and you can calculate them. So I think the best way to do this, so this lecture slide says very clearly, this gives you a quantitative measure of to the degree of the system, process, or component with using this given attributes. Okay? So these are the metrics you can use. So I think the easiest way to do this is, let's look at the tutorial. The first tutorial is based on this, and you see how the calculation is done. I think you won't be able to do it, but let me do it and show you. Okay, so the question here starts with, now this table, just like the one you have just now, let me zoom in, everyone can see it back. Yeah, thank you. So this one, it says, okay, same like the slide, we have team A and team B, non-normalized, this one, the figures are almost the same, and they ask you to normalize with clock. How do you calculate that? Okay. So the question is, the request is normalize the metrics of project team A and project team B with clock, thousands of lines of code. Use the normalized metrics and compare the quality of both the projects. Okay. Then provide comments and analysis of both projects. So let me show you, before I show you the answer, let me hide the answer first so that it makes more sense to you when you see what we are doing. If I show you the answer straight away, it makes no sense. Where is my tutorial? Hold on,
So the metric you refer to what? The metric itself.
This is for quality. Yeah, for quality metrics. Okay, so before you see all the answers, let me just hide them first, then we talk through it together, and then hopefully it will make more sense. Okay, so I've hidden it already. Let me zoom in. Okay, so what you do essentially is first you have to normalize the number of lines by dividing it by 1,000. Okay? So in this case, they have even more differentiation. This project from team A is using Java to do the coding, and team B is using PHP. So they're using different technologies. So the way you normalize it is you divide it by 1,000. So let's see here. No mouse already. Okay, let me highlight it here. So in blue, so you normalize, you take the lines of Java of code and divide by 1,000 and you get a number 306. Then you take the quantity fee, divide by 1,000 and you get, you say 256, right? So you get 256. So you get those two numbers. So now it gives you a sense of comparison already. What did I do? So, sorry.
Why do we want to normalize?
You hold on for a while, you see the answer, then hopefully it will make more sense. Yeah, average how many errors? Why am I not doing this correctly? My fonts are okay. Okay. Okay, so basically now the purpose of doing this is to normalize it so per 1,000 lines of code. That's why it's called clock. So this number that you get here is the clock number already, lines of code. Whereas this one is just total lines of code, 306,000. But when you want to compare the clock, to normalize it, to divide by 1,000, so you can compare apples to apples. For 1,000 lines of code, there are, if you take 1,000 as the base, this is 306, this is 256 lines of code. So you can see it. So that's one. Then you take the errors and let me show you the answer and then we'll refer back to the question. I think you need to see the question for this. Okay. And just select it. Sorry, I'm so used to the mouse, my trackpad skills are not very good. Okay. So this one, you take 288 divided by 306 because now that you've normalized the number, now you can find you can take the number of errors divided by 306. So you want to see how many errors you get in 306 lines of code. That's what it is basically. Then you get a number 4.9412. Then you do the same for project B. You take 233 divide by 256. Alright, because that's the lines of code. So you get a factor to show you how many errors you get for this line of code, but now it's normalized already in the figure. You do the same thing for defects, and I'm just going to highlight everything now, so we will do one by one so you see how it's done already.
Okay.
You do the same thing for the number of defects and the number of pages of documentation. So let's look at the analysis here. So the analysis here shows us that project B has lower errors compared to project A. 0.9102 is lesser than 0.9412. Okay. Then project B has also lower defects, 0.781 compared to 0.0980. And project B has more pages of documentation compared to project A. And that's a good thing, for pages of documentation. If you have more documentation, the implication is that the system must be easier to maintain because you documented so much of it. So that's the thinking now. Okay. So that's the logic for it. So the conclusion that you can come to is that yeah, project B has better quality than project A. So this is how this technique allows you to come to a quantitative value for quality, right? Otherwise, how do you measure quality? Quite difficult, right? I mean, we tried to do it just now with our our quality plan, right? That's one way of doing it. But that's just whether you meet some quality attributes, whereas this one gives you a whole project field and allows you to compare one project to another project. Does the calculation make sense? Yeah, makes sense, right? First you have to normalize it, then you can start comparing your errors to lines of code, defects to line of code, documentation to line of code. And the difference between errors and defect, the way I think about it is error is bugs that you found during testing. Defects is bugs that the users found while they are using your live production system. Okay, so I've did some more research to give you the logic, which is what you're trying to understand. Why are we calculating all this? What does this tell me? What does those numbers tell me? So the total line of code gives us an idea of the size and complexity of our project, right? Obviously, if you have more lines of code, it must be much more complex, right? So when you compare lines of code with another project, you can tell is one project more complex than another. So this is a technique to compare complexity for lines of code specifically. Total errors, of course, total errors tell you how many bugs you discovered during your testing. Yeah, so this one you can compare. Total defects, as I said, helps you figure out hey, your testing was good, you all have enough good quality control during your testing. Because if you still got bugs after you release the software to the users, which is the defect, that means it might tell you that your software quality control is not very good. Right? You still got a lot of bugs. And it allows you to compare different projects together. And the documentation really shows you that whether it's easier to maintain, to use, and onboard. Onboard means to bring new developers into your project. Because if you've got more documentation, it should be easier to maintain. It should be easier if a new software developer comes in, you can read the documentation. Because there are more pages. Okay. So it's a bit unusual, I know, counting the pages of your documentation. Yeah?
So the pages is more pages.
More pages better. Yes, correct. More pages imply that it's easier to maintain the system because you've documented the system pretty well. But of course, if you have a lot of white space in your pages, that's a bit cheating, right? If you have a lot of empty pages inside, so you shouldn't do that. So basically, what we just did, the lines of code really tells us which project is more complex and larger in scale. The total errors tells us a bit more about quality control. Total defects, which is easier to maintain or support more, also quality control related. And finally, which resource type I will use efficiently. This is one way to measure. The other way to measure is in terms of maintenance, in terms of onboarding, in terms of usability for the pages of documentation. So this, what we've just done, we've used this technique to calculate it. So you will see it in your lecture. Hopefully this makes it clearer, because in your lecture there are a lot of slides about it, so hopefully this makes it clearer for you. Okay, let's look at the next one. Okay, the next one is a little bit more involved, a little bit more complicated. Okay, so I will explain a few things to you. Hopefully it makes more sense. Let me get my notes out. Okay, so this one I definitely will have to explain a bit more. Try to follow along because there are a lot of components here. So what this does, function point analysis, it takes the perspective of, instead of looking internally at the lines of code, it takes a look at how from the user's perspective, how many input fields, how many output fields, how many reports, how many query screens. I'll show you in your notes, you've got lots of different categories. Okay? And this is what I was talking about, number of input fields, number of output fields, number of inquiries, number of files, number of external interfaces. 1, 2, 3, 4, 5, 5 areas. So you literally, somebody has to sit down, go through your whole system, and every screen, count how many input fields there are, and total them up. So it's very involved for somebody needs to sit down and do this, okay? And what you can do is you can put a weighting factor for every type of category. So if you have the weighting factor, there are 3 categories: simple, average, complex. Okay? The numbers here, the weightage, you put the numbers. Okay? But there are 3 categories: simple, average, complex. So for example, simple can be 1 and 2, but in this example they use 2 only. Average can be 3 and 4, and complex is 5. That's the weightage you can give. Okay? So you know a weightage means you put a higher number to the more complex one, the simple one you put the lower number. Okay? So in this case, what has happened is that they have counted everything and they found out that in project A, there are 4 input fields which are considered complex. There are 6 outputs which are considered simple. Of course, they put the number very small, right? It can be very big, right? And so on and so forth. And they did it for project B as well. Okay? And okay, this is another new variable that you will have to remember. Then there's another variable that you have to use to calculate it. And they call it the sum of Fi. Yeah, I know. I hate maths as well, right? But it's nothing complicated. This sum of Fi is a number you give, I'll show you, it's a number you give to indicate how complex the whole system is. And there are a couple of variables, you calculate, you get a number. The max I think is 70, if I remember correctly. So in this case, so the bigger the number, the more complex the system is. Okay. So in this case, project A is 50, project B is 40. So this one is definitely more complex than this one, just looking from the sum of Fi. Okay. So let's do the calculation here first before we go to the next part. Okay? Let me show you the answer. Then hopefully it'll make more sense. Okay. So let me find all this. Okay, don't look at the bottom one first. Let's just calculate the top one first. So essentially, you take the weightage and you multiply it by the count. So it's as simple as that. 5 times 4, 20. 4 times 5, project B, also 20. Project A, 6 times 2, 12. Project B, 5 times 2, 10. You get it, the picture, right? So you just apply it to the weightage and you multiply it. So I'm going to just quickly highlight it again. So then you sum them up and you get the total count based on the function point. And based on the count. Okay, where is it? Okay, so you get 80 and 70 when you total all that up. Then remember in the question, they gave us the variable sum of 5 for project A is 50 and sum of not 5 Fi. Sum of Fi for project B is 40. So I was telling you earlier, the sum of Fi indicates how complex the system is, right? And there are 14 categories of complexity. The maximum answer is 5 per category. And if you have the most complex system, you take all 14 categories, you give them a max score of 5, you get 70. Okay? But in this case it's not like, in this case it's only 50 and 40. So at this point, what I'll do is I'll switch back to your lecture notes and show you where these categories are. There's a lot of stuff in your notes. Yeah. Yes. The table they will provide, and likely they will provide the sum of Fi, so you don't have to calculate the sum. Yeah, you should fill in the table only. Yeah. Okay, let me find that slide. Put down the slide number. So the sum of this one, Fi, there are 14 questions you have to answer. And each question you can give it a value of 0 to 5. So 5 for the most complex, 0 for the least complex. Okay? So are data communications required in your system? So if there's a lot of data communication that is very complex, you put 5. Are there distributed processing functions? If there are, you put 5. So you answer all these questions, give it a score, and if you put all 5, you will get 70, which is the most complex system you have. So it's a degree of complexity, and you apply it in the formula, which is what I will do now. I will go back to your tutorial here and show you. So in this case, it's very easy for us because they don't ask you to calculate, they already give you the answer, the sum of Fi, right? Okay. So now, to calculate your function point, here is the formula. So now only we are calculating the function point. And the function point is the count total, which is this 80 or 70, multiplied by 0.65 times 0.01 times the sum of Fi, which in our case is 50 for project A and 40 for project B. So we apply the formula. So the formula, I don't know in your lecture, whether in your exam they will give you the formula, but I think over here they did. Okay? So they did give you the formula for the function point. So if you get the formula, it's very easy. So you just do it. 80 multiplied by 0.65 plus 0.01 multiplied by 50 here is the sum of Fi. You get this, you get 92. You do the same here, you get 73.5. And what these numbers show you, to be very clear, is that 92 here, this indicates that project A is a larger, more complex system that offers more functionality. And this is a smaller number, it just tells you that this is a smaller or simpler system that offers fewer features. So they can tell you this, they can come to this conclusion because they see it from the point of the user in terms of functions in the system. That's how they get to this. Okay. So that's one part of the question. The other part of the question, in your tutorial, they give you this part here. They give you these details here to tell you that, hey, we also know the count for the defects and the pages of documentation for project A and project B. So they said, can you calculate based on your answer of this function point, calculate what is your defect rate and your documentation rate. So let's see how we do that. So it's actually very simple. We take the number of defects found, which is, let me see, 90, is it? The original one? Yeah, 90 in project A, 90 defects, and you divide it by the, let's see, by the function point for project A, which is 92. Remember we calculated 92? You get the number, and you do the same here. The number of defects for project B is 70, and you divide it by the function point number 73.5, and you get a number. You do the same thing for documentation. And what this tells you, the conclusion is that project B, 0.95, has lower errors compared to project A, and project B has more pages of documentation, 1.77 for each function point, compared to project A, 1.3 pages of document for one function point. Okay, because you divide by 92, you get per function point, right? So what does this mean? This means project B has higher manageability because higher manageability, higher quality than project A. Firstly, because the number of defects found is lower and the number of documentation pages is higher. Okay? But this one, remember this one takes the view of from a user perspective because it counts by function point. This one takes the view of internal lines of code. That's why this one measures productivity. This one measures maintainability and quality. This one here, sorry, these two here. What we need is these two. So the first part of the table up here was number 2. And this second part of the calculation here to number 3.
Yeah.
cannot hear ah,
From the question. If you look at the question, project A, defects is 90. Right? It's a tutorial question. Yeah, no, it's normal. When I first did it as well, I said, where did the 90 come on? Then I look at the tutorial question instead. So you have to look at the 90 from the tutorial question. So, so what are we trying to compare here? What we just did is what we are trying to compare whether which project has better maintainability. If your project has better maintainability, it implies that it has better quality, right? It's easier to maintain. The project must be quite good quality, right? In terms of fixing bugs, updates, and easier to understand how the system works, right? Because of the documentation. So to do that, we look at the defects per function point. So we did all of this already, right? We calculate defects per function point, which is this one, right? And what that tells us is how many errors, because we did errors, defects, were found for each unit of functionality. So we are not, this time, we are looking from the user perspective functionality, right? So now we can tell, oh, okay, this one, there are more errors in this one, so this one is not so easy to maintain. Or the quality, or the other way to say it, the quality is not as good as the other one. Then the documentation also implies how easy it is to maintain, okay, per function. Okay. More documentation means the system is easier to understand and maintain. So if it's easier to understand and maintain, it's better quality system, right? So that's how you get it. Right? So the final analysis, which is what you saw just now, is this. Then the conclusion, we saw it just now, right? Project B is better quality, easier to maintain, because it has fewer errors per function point and more documentation. So because of that, it's easier to fix, easier to maintain, and easier to understand when new developers come to join my team. This project is better to understand. Yeah. And so hopefully I've helped you think about all these three different types of calculation in helping you quantify software quality. So it's a metric for you to use to calculate, because otherwise software quality can be just agak-agak, right? So this one gives you a quantitative way. Yeah, it's just agak-agak. I think it's this one. So now you have a software metric to help you calculate quality. It's not perfect. If you think about it, the counting of functions and the complexity is a lot of work, right? You have to count everything, and then you have to answer the 14 questions, and that one also depending on who answers the question, right? Because you can put 0 to 5 for your 14 questions, right? So it depends how you answer the question as well. But at least it gives you a way to compare. Otherwise, there's no way to compare. So this is 3 ways to compare. Okay, so hopefully when you see your lecture, all these things make more sense. Because I look at your lecture notes, wow, it's all over the place. So these are the 3 things for you to remember. Yes.
I observed that the lecture is more theory one, the tutorial more calculation. So
it's a mix, right? In our tutorial we do theory and
mostly.
no, last week we did, remember the slightly boring quality assurance, quality planning, quality, more theory, right? But your lecture, doesn't your lecture walk through you how the calculation is done? Oh, you were there, no? Because like, software project management, last time we learned how to calculate EDM, net present value, NPV. Did your lecturer walk through exactly how it's done? Or just show you the slide in it?
Just everything follow the slide exactly.
Just follow the slide in it. So if you don't understand the slide, sorry, you cannot follow.
He doesn't care.
No, I can't blame him. Like, he's so many students, how is he going to explain one by one? Understand? That's what tutorial is for.
That's why you just play this guy very busy. The lecture always comes down.
He talked with me, then
You kena.
I kena.
你看这里面有点吗？
No, you talk with me, then I
All okay.
kena.
小心啊，小心，小心啊！不要小心啊！
Which third one?
这可以有了，真
啦，
给我回去小学的时候。
This one.
小学。他意思是他想猜到你想要
Okay.
够不痛？
I want to ask this side. Okay. Let's follow.
够。
我就问你，你是讲妈妈的嘞？这边有。
我对我
澳门，还动的，还有个走。
Okay. That's all I wanted to do today because the next one is more theory. We keep for next week. Okay.
Enough.